This year sees the first international effort to deflect an asteroid's trajectory. Romania is one of the countries contributing to the European component of the mission. Romania will provide some key elements for the success of the European mission. The Romanian expertise will help Hera to reach the asteroid and measure its deflection very precisely, following the impact with DART. It will also support one of ESA's first two deep space cubesats to approach the asteroid. Basically, everything the mission satellite will see, as well as the way the data is interpreted to guide it to its destination, will depend on Romanian technology, which GMV Romania experts are currently working on. Part of an international consortium, GMV's Romanian subsidiary will be responsible for image processing, altitude-based guidance, error identification and isolation, and the image processing-based navigation of Hera's main satellite, as well as of a smaller probe that will get closer to the asteroid, Juventus, one of the European Space Agency's, ESA, first two deep space cubesats. Why deflect an asteroid? NASA's DART mission is heading towards two asteroids that form the Didymos binary system. NASA's spacecraft will intentionally collide with the smaller of the two asteroids on September 26, 2022 to see if it can alter its orbit. ESA will then send its own mission to the two asteroids to observe in detail what happened after the impact. The Hera mission will measure the asteroid's mass and composition, analyze the crater caused by the collision, and help us better understand the asteroids. In addition to the main satellite, Hera will also have two smaller probes, Juventus and Milani, which will get much closer to the asteroid, to collect scientific data and then land on it. This information is essential if we are to defend our planet from the threat posed by asteroids. To solve a problem effectively, you first need to know it very well, explains Cristian Corneliu Citu, Director of Space at GMV Romania. So far, the scientific community has incomplete information about the asteroids, and the mission is based on theoretical knowledge, which has not yet been validated. We want to know what the asteroid is made of, whether the surface is metallic or covered with ice, whether it heats up or not, how it reacts when the asteroid enters the shadow, what information the infrared images will give us. All this data helps us better understand asteroids. Hera will also measure whether or not the deflection attempt was successful. We'll see how far the satellite asteroid will have moved relative to the center of the binary system and how the trajectory will have changed. Based on the information gathered, humankind will know how to better manage risky situations involving asteroids. In the future we will know how big the impact should be and where we should hit an asteroid. At the same time, we will learn what kind of resources are found on asteroids and whether we can use them for the benefit of humanity, added Iulian Emiliu Haas, Head of Space Segment and Robotics, GMV Romania. The brain of the Hera mission, tested with equipment made in Romania. In conclusion, Hera plays a vital role in the first planetary defense mission, helping us not only to better understand asteroids, but also to test our capacity to change the trajectory of a potentially dangerous asteroid. Thus, when we might need to deal with a dangerous asteroid in the future, life on Earth itself may depend on the mission functioning correctly. In testing the Hera mission, ATOS Romania makes an important contribution. The Romanian team has built the equipment involved in the testing of the data management system, including the mission's onboard computer. This equipment, officially called the Data Handling System Special Checkout Equipment, consists of hardware and software components, connected to the data management system. This is made up of the onboard computer, the internal memory and the terminal units on the platform, payload and propulsion. The equipment is already used for validation by Kinetic, the Belgian contractor, says Cătălin Dumitru, the company's project manager. The equipment developed by ATOS Romania allows the simulation of an impressive number of scenarios that might be presented to the onboard computer, based on data from a great number of sensors and interfaces. This is how the onboard computer and the data management system can be observed, validated and diagnosed during the integration phase of Hera. The equipments produced in Romania are testing Hera's communications with the Earth. ATOS Romania also produces two other pieces of critical equipment for the Hera mission. The first is the radio frequency special checkout system that is used to test bidirectional communications between the satellite and the ground stations. Moreover, ATOS Romania produces another equipment that simulates the behavior of ground stations and validates that the mission correctly communicates with them. As the mission relies on data and commands being transmitted through telecommunications, the Romanian team contributes to the faultless functioning of the mission. Currently, the equipment for testing the onboard computer was delivered to the Belgian contractor, Kinetic. Work for the other two pieces of equipment is still in progress, says Lucian Valentin Molevin, sales director at Atos Romania. Hera has Romanian eyes. To reach the binary asteroid Didymos safely, the Hera mission will be guided by a system designed in Romania. GMV is developing a guidance and navigation system, GNS, based on data analysis from the mission's cameras and sensors. Using algorithms designed in Romania, teams on the ground will know whether the spacecraft is still heading towards the asteroid or has deviated from the established trajectory. If the spacecraft needs to readjust its trajectory, the commands received will be translated into a signal that the vehicle can interpret and execute, also using GMV technology. Hera's journey to the asteroid will take more than 2 years, and the landscape will change several times along the way, so the mission's guidance will need to be different along the way. At first, the asteroid will be so far away that there will be only one pixel on the mission camera, gradually turning into a cluster of pixels. During this phase, the GNS system will rely on keeping the asteroid in the camera's field of view so that the mission is always aimed at that point, says Iulian Emil Juhas. As Hera approaches the asteroid, the guidance system must take other factors into account, constantly calculating where the center of the asteroid is and how it is moving. When the mission gets close to its target, the asteroid will cover the whole image, so the mission will have to switch to a different type of navigation. In this case, we need to detect landmarks on the asteroid, such as boulders, craters or ridges, anything that has a clear shadow. This way, we can understand where the mission is in relation to the asteroid, continues Iulian Emil Juhas. We are responsible for the safety of the mission. A team on the ground will see the same images and in parallel use the same algorithms developed in Romania, so they can compare the data with what is happening on board the satellite. If there is a big difference between the two locations, something is wrong and the vehicle will go into safe mode, explains Iulian Emil Juhas. In turn, the fault detection, isolation, and recovery, FDIR, system aims to identify if sensors are malfunctioning. For example, if the space equipment records data far outside the expected parameters, or if there are very large differences between two consecutive sets of data without other sensors confirming the situation, the system designed in Romania will identify the error and isolate that sensor so that its data are not passed on to the onboard computer. Identified errors may even include collision danger with the asteroid. In this case, the command center on Earth will guide Hera. In emergency situations, where communications cannot be fast enough, the mission goes on autopilot. The Juventus Satellite is partly built in Romania. Romanian innovation will also be present on the Hera mission's payload, Juventus, which is extremely important for better understanding asteroids. This is a small satellite, a cubesat, that will be launched from the main spacecraft and reach the target asteroid for close study. Once in orbit around its target body, Juventus will open an antenna larger than its size to carry out the first underground radar survey of an asteroid. The radar signals should reach a depth of 100 meters, providing information about the asteroid's internal structure. During the flight, Juventus will also gather information about the asteroid's gravitational field, and will eventually land on the asteroid if the conditions allow it. This last step will provide information about the impact force, rebound and surface of the asteroid. All this will be possible thanks to the Romanian contribution. Juventus will use the same Romanian technology for guidance and navigation as Hera. Moreover, 1/3 of Juventus is made in our country. The Romanian team is responsible for defining the mission, choosing the operational orbits and planning the mission step by step, from the launch from Hera to the asteroid landing, says Iulian Emil Juhas. Unique experimental system in Europe, 200-fold improvement in computing speed. In space missions, physical space is extremely precious. For the Hera mission to perform at its best, and to collect and process the data it receives, it needs extremely high computing power, for which it has very small components and low power availability. However, an innovation by the Romanian team will allow up to 200 times faster computing speed. Hera will be the first European mission to test this system, loaded on board as a payload. Basically, the team has added an extra piece, a field programmable gate array, FPGA, to take over some of the calculations. The result is similar to the presence of an extremely powerful processor that consumes less power and is 200 times more efficient. The system is fully developed, tested and flight qualified by GMV Romania together with its partners. The success of the mission, measured with Romanian expertise. After the impact with DART, the Hera mission will reach the asteroid and make a detailed survey with several instruments on board. Among these, the altimeter is the only instrument that will be installed on Hera to measure the distance to the asteroid and determine the new orbit following impact. The altimeter is capable of measuring the distance of targets near the satellite from 100 meters to 15 kilometers with an accuracy of 0.1 meters. It will send a laser beam to the asteroid and a telescope will capture the return signal. Using this method, researchers will be able to calculate whether and how far the Dimorphos asteroid has moved from its original position. The optical design of the altimeter was entirely developed at the National Research and Development Institute for Optoelectronics, INO 2000. The participation in the development of a scientific instrument under the coordination of the main contractor, FACE Portugal, in the context of an international NASA/ESA mission, stands as proof for Romania's expertise, appreciated at European level. INO is developing much more sophisticated instruments than the one on the Hera mission, but for terrestrial use, explains Dr. Anca Nemec, INO manager, the biggest challenge of this project was to adapt our technologies and knowledge so that the altimeter could work properly in the extreme conditions of space. To qualify an instrument for flight is almost as complicated as to develop an entirely different device. The INO team had to rethink everything from special materials that had to withstand the shock of space launch and extreme temperature changes, to selecting suppliers with space experience, to testing the instrument's functionality in special space conditions that are so different from those on Earth. In space, we work side by side with other European countries. Even though the Hera mission takes place in space, some of the benefits will be felt at home, in Romania. At the moment, there are only 4 countries that develop this image processing component for space: Spain, France, the UK and Greece. The component is essential in space missions, so the knowledge and know-how thus acquired will be useful in a wide portfolio of space activities: lunar missions, Mars missions, active means for space debris removal, orbital maintenance services, in-orbit assembly services. In addition, Romania is strengthening its reputation in space research and development. This is one of the few areas where we can say that we are working side by side with countries in Europe, thinks Cristian Corneliu Citu. The RAN side is appreciated as much as anywhere else in Europe. In fact, advances in image processing, on which the Hera mission's navigation is based, can be replicated in other industries. We take terrestrial technologies, improve them and then reintegrate them into commercial technologies on Earth. It's a spiral system through which we evolve. The developed technologies could be used in industries such as the automotive industry to improve autopilot performance. From a broader perspective, the technology can be useful in robotics development, for example, access to difficult areas such as mines, radiation zones or simply hard-to-reach areas. Optical processing also plays an important role in the autonomous movement of robots in warehouses through landmark recognition, or the development of robots working on assembly lines that need to be able to count, move objects or sort them according to color or shape. The benefits of collaboration with ESA and Romanian expertise recognized at European level. INO's collaboration with ESA started in 2014, with the Multiply project, which developed a multispectral LiDAR. Based on that performance, INO started to be recommended at European level in 2017. FACE Portugal, the prime contractor, contacted the INO team for the Helena project. As part of this project, the team developed the concept and the first miniature prototype for the future Hera mission altimeter, to demonstrate the feasibility of the concept. In 2021, the PULT project continued the work started with the development of a larger prototype and then the development of the final instrument, which will be launched into space aboard Hera. In addition to the optical design of the altimeter, INO has also been involved in the procurement of the parts that are used to build the instrument and their testing. As we are involved in all stages of the project, from concept development to building the prototype and then qualifying the instrument for flight, The Romanian team is being exposed to extremely valuable knowledge gained over time by teams in Europe, explains Dr. Nemec. The Hera involvement has undoubtedly contributed to the consolidation of the expertise accumulated and multiply in the development of new skills that strengthen INO's competitiveness in the space field at European level and beyond. The instrument is currently in the construction phase. Drive Livio Bellegant, leader of the INO technical team involved in Hera, will travel to Portugal this autumn to participate in the final assembly of the instrument and the tests corresponding to this phase. A team of 4 researchers and engineers from INO was involved in the Hera mission. This was the 5th episode of our project. Please subscribe to Radio Mars Ultor and press the bell that will notify you every time we talk about a new topic.